So I just want to discuss exponential functions pretty quickly. It's not going to be a long video. Y equals e to the x, our friend the exponential function. Technically, exponential functions are anything y equals some b to the x, where b is the base, b being just any number. So you'll see 2, 3, 10 in this class. We're basically using e being the natural logarithm, right? 2.718, something like this. We'll talk about that a little bit in a minute. But let's be more general. We'll see what's going on with this graph. You can imagine, of course, as x gets very large and positive, we're going to take b bigger than, well, let's start with 1. Let's say if b equals 1, what does that give us? Y equals 1 to the x. Well, that's just 1. So that would just be like this line here. Okay? Well, now if we take our number bigger than 1, it turns out we do get this shape like this, of course. And as the base number gets bigger, this gets fatter. So I don't want to bulk up my graph too much because there's not that much space. But if I did say y equals 10 to the x, 10 being significantly larger than e, right, I'm going to go up faster on the right-hand side. And on the left-hand side, as we know, right, because if I'm taking negative values in x, I'm putting that in the denominator, so those are getting smaller and smaller. So with a larger base, it's going to get smaller faster. Okay, so basically that's the idea, right? Now, as you remember your laws of exponents, right? If I have a negative, it's like 1 over. Similarly, if I took something that was, say, smaller than 1. So let's say I take 1/2 as my base, right? This I could also write as 2 to the negative x. So I could take my 2 to the x and just flip it over, and then that makes sense as well. So let me write that one here, say that was going to be this here. Get rid of that one, which is 2 to the negative x. So, oh, that doesn't look good. It's supposed to be the same shade. 2 is smaller than e, so it's not quite as, yeah, something like that. Anyway, if you look in the book, they have a nice graph of this where they have a bunch of different b's, and so they give you some idea of what's going on. So I could write this as 1/2 x, or if I prefer, I could just write it as 2 to the negative x, which is kind of a nice way of thinking about it. In any case, that gives you the exponential function. As we know, if I take my e to the x here, if I take x very large and negative, I'm going to get something which approaches 0. So I have a horizontal asymptote over here on the left-hand side. Never gets there, but it approaches there. And let's double check that we remember all of our laws of exponents, right? If I have b to the x plus y, that's b to the x times b to the y, b to the x minus y, right? Because if I do a minus, it's 1 over. So this would be b to the x over b to the y, right? If I have b to the x to the y, then I'm multiplying those exponents, right? So raising to the power is multiplying exponents. Multiplying is adding exponents, okay? And if I have 2 different bases, I don't know exactly how often you see this. If I have this, I can write this as a to the x, b to the x. But if I have a to the x, b to the y, I can't do anything with that, right? Unless I can somehow, unless one of these is a multiple of that or some weird thing like that. In general, if it's a to the x, b to the y, I'm done. I can't do anything with that. So that's just some very quick discussion of laws of exponents. What else do I want to talk about? E. Oh, I want to talk about actually the number e. So there's various ways to define or why we choose this weird number e, which is an irrational number, and what is this e and why do we use that? So I just wanted to discuss briefly. I think most people are introduced to it first through the medium of compound interest, okay? Where if your interest is compounded yearly, then monthly, then daily, and then you try to do instantaneous interest, it turns into E. Well, funny thing is, what is that? When we're going from something discrete to something like continuously compounded, this is a limit of what we're talking about on the first day. This is what we're going to talk about in calculus, and you'll see that this number E comes up in calculus many different ways. It comes up as an important limit, and it also comes up when taking derivatives, and I wanted to just point this out, that you will see, here's my thing, right? Let's take this. This is y equals b to the x, right? If I look at what's happening at the point at 0, and remember on the first day of introductory calculus, we talked about something about tangent lines, making a tangent line. So if I look at the tangent line at 0 here, it looks like that, right? And as my curve, as my b changes, as my curve gets bigger or steeper or less steep, the slope of that tangent line is going to change, okay? Well, it turns out one of the special things about E is that if this isn't B, but I actually say I didn't draw it well because I can tell it's not E. I can tell it's not E because of the fact that the tangent line had the wrong slope. Okay? So if I do E, it's a little bit more like that. And my tangent line has slope 1 at the point x equals 0. Is this like, it seems weird, like who cares, right? It's just kind of an interesting thing. You'll see it again. It kind of adds, a little bit of, when we talk about this, so what that's going to mean is that the formulas, when we have this e to the x, are going to be simpler than with any other base. And that's really what it comes down to, using e and using natural base, and then of course using natural log. The formulas are going to be simpler. That's why I like to use it in this class and not worry about like 10 to the x or whatever, right? Because I'll forget. Not that it's significantly, it's not more complicated, it's just you have more constants and it's kind of ugly. So we'll see later how to get this and how this works out. In fact, some people define E this way. They define E as being the number that makes this slope 1. We are going to define E in a different way. We don't have to worry about that right now. But I just kind of thought this was sort of an interesting thing to talk about.